In the beginning, there was nothing. And then, bang, AEL was born. Astro's Electronics Lab brings you entertaining, sometimes silly videos relating to electronics for your enjoyment. Follow along with his frustrations and antics and maybe learn something in the process.
Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Cheers. Well, today is the day that I'm going to replace the transistors, all three of them, because this one's shorted base to collector, and the output stage with some new ones. Got another couple of MJL 21193 and 94s, a BD139 and a 140, and there's a other BD139 knocking about from the last purchase when I was doing this channel. So I've got all the transistors I need plus two new fuses. So that's what I'm going to be getting about doing. I'll remove that for now. I'm going to pull these transistors off. I'm going to replace them. After checking other things like these two input transistors are still fine, I'm going to reset this to around 560 ohms. And then we'll do a dim bulb low power test into a load. Then we'll do the full power test on this channel alone. I'll isolate this one by removing the fuses. And then, as nervous as I am about doing this, do the final bridged power test. And hopefully it doesn't go off with a bang and end in magic smoke again, because that would be rather disappointing and depressing. So let me get about to removing these transistors, and yeah, we'll come back when I've got some more progress. Right, I've got the transistors out of the board now. It was a bit of a struggle with the output ones, but anyway, here's the BD139 that's shorted base to collector, well, at least I believe it is. So just going to test this transistor. Dead short. That's base to collector. And base to emitter is no longer there. I assume I've got that the right way around. Base should be on the left of the device, so emitter's over there. So yeah, when it's turned upside down, but so that means that that's now on the left. So that's base, that's collector, it's dead, and the emitter is open. Isn't that wonderful? Check the other way around. Nothing. Dead short. So that transistor is buggered, so that can go in the bin. Check this other one over here, BD140. So that's PMP. Good junction. Good junction, not shorted. So that'll be in my suspect pile. Check this other BD139. If I can get a good connection, good junction, not shorted, but I'm not going to trust it. So that goes in my suspect pile. And the 2S C that I pulled off, MPN, just to make sure that it's still functioning. Yes, yes, not shorted. Okay, so that'll go in my transistor box for later testing and something else. Maybe I'll blow them up in another video, I don't know. The 2SA, good junction, nothing. Okay, so we know that that BD139 that I threw out was bad because it, well, had no emitter junction anymore, and it also was shorted base to collector. One thing I need to do, I haven't done yet, is to adjust the resistance of that trim pot, because I don't know what it's set to at the moment. So what do we got here? We have 436 ohms. So I'll wind him up a turn or so. we now have 500. So I'll just give it another turn. Tedious process, but just want to make sure that the VAS and the, there we go, 560. The VAS and the output stage is not going to initially just blow up because the resistance was too low on that side. Now, I have to put the new transistors in and then begin testing. I am very nervous, but very excited at the same time. I think I might replace this sill pad as well, because that's the one that got burnt. So I'll just borrow the sill pad off of the other heatsink, wherever that's gone, that I was using for testing stuff. Oh, it's right in front of me. I'll just borrow a sill pad off of that because they're brand new. So because this transistor doesn't actually fit the footprint, because it's designed for a TO247, I think it is, not a TO263, 264 I think this case is, a 264. I'll just take a screwdriver, a bit like a lady slipper, and then I can apply some torque in the opposite direction to line up my hole. So I can get the screw to maybe go through. And that's all I was going to do there to make it fit. As I said in the last video, these transistors do fit, but they will be bent at a slight angle more than, 90 degrees, probably more like 80 degrees. No, probably not that sheer of an angle, probably 85 degrees. So I'm going to do the same to the PNP. That's the annoying part about the numbers being backwards on these devices, because it goes MJL21193 for the PNP and MJL21194 for the NPN. You would think the NPN would be first, like it is with the TIP35C and 36C respectively. It goes NPN then PNP. But no, they decided to be backwards on this one. So, grab my sill washer and I will pass him through the hood, or hoods. Bit of a tight squeeze. That's what she said. For some reason that doesn't want to go through. Might be because I don't have that emitter hole clear enough. Let's try that now. Now, something's blocking me. It's got to be that emitter hole. Let me see if I can clear that up a bit better. Hopefully I'll suck some stuff out then. I'll have to take this board outside and, there we go. I'll take this board outside, turn it upside down and shake it so I get anything loose. Some bits of solder dags removed from the top surface so it's not causing a potential short. Right, that's the screw in, both screws in, make sure both sill pads are straight, and then I can remove my solder that was propping the edge of the board up, and then I can apply some mounting force to it so the transistors are permanently mounted to the board, and then solder them. It's always a good idea when mounting transistors flat to something like this, like a heatsink, or even mounting it vertically, I suppose, is to get the thing in the holes and then put this mounting hardware in, torque it down, and then solder the pins, because then the transistor leg or the IC legs, depending on what it is you're doing, will find their own position to any discrepancies in differences in height of the PCB. In other words, if the PCB's got a slight bow in it, it'll conform to that. rather than solder it in first, then torque it down, and then run the risk of either cracking the component or just basically damaging the circuit board. So I'm going to solder these transistors in now, and then I'll pop a couple of fuses in and we'll do some preliminary tests. I will double check that the transistors are good that I put in. They haven't miraculously failed in being installed. Okay, so I'll just cut off the excess length. That's the good thing about this particular case style. The leads are nice and long on them, whereas the 247, TO247, the leads aren't that long, and they barely make it to the circuit board surface with enough sticking out to solder to. So, PMP, good. If I can get to that leg, good. Not shorted, good. Good. Not shorted. So now the next thing to do is, I'll need this because I want to see the DC offset on the output, is to pop a couple of fuses in. I'll just pop the ones I took out the other side in here and do some power up tests. Alright, I've got everything set up. I've got the dim bulb off to the left here, transformer. I've got the left, well this is the left channel, hooked up to the multimeter on the red lead here. And ground, and we're going to see what the DC offset is. So that's coming after the relay. So I will turn the dim bulb on. Nothing unusual. Oh, nice. About minus 30 millivolts, which is okay. So I'm going to see if I can adjust that potentiometer to bring the DC offset down to 0, go into millivolts. So I got more like minus 2 there. So if I touch the input, see how it's jumping around. So we now know that that's working as an amplifier, and that's about as close to 0 as you could get, although it's come back down a little. So I'm just going to back that potentiometer off. It's a good idea, I'm going to bypass the dim bulb too. No, nothing. It's a good idea to let the amplifier stabilise when doing that adjustment, or on any amplifier that has one of those adjustments, so check it again after 5 minutes. But for now, that's working. So now we'll do a basic load test with the dim bulb in circuit and see if we get an output. And yeah, those transistors were getting warm, but don't forget there's like 150 mA of bias current there, so they are going to get warm. Okay, the isolator is connected, so give it a bit of power, and right, currently I don't see an output. Oh, there it is. So let me increase this. Right, it's going in clipping. So I'll bypass the dim bulb. Whoops, that was the wrong switch. Alright. Here we go. Right, that's clipping, and I can't really see the signal on the scope because the division's too low. So I need to increase that so I can actually see what I'm doing. Right, let's try that again. Now I've got them too high. Ah dear. But there's no smoke coming off of it, which is good. That's a good sign. Hardly much heat there at all. gets the full power clipping, and then we have it there. Now it should be in times 10 on the scope, but it's not, it's in times 1, so that's 19.5 volt RMS. Turn that down. There's our 47 watts, so it's the same as the other channel, roughly. Okay. I need to reconfigure this for 4 ohm, because at the end of the day that's what each amplifier is going to be driving bridged. Alright, here we go. Dim bulb's back in circuit. Yes, we've got an output. Alright. Bypass the dim bulb. Here we go. Bang! No, just kidding. Clipping is there. So that's about right. 16.8 volt RMS. Turn that down. Actually, nothing is smoking. Excellent. Alright. So 70 watts RMS. I can't remember what the other one measured at, but yeah. Because it was like last week. Alright, so we now know what that means, don't we? It means bridge the amplifiers. I've got to put the IC back in to do that. I want to make sure though, I'll remove these fuses again. Quite a bit of heat in that now. I want to make sure that the output here is coming out with one out of phase with the other. Alright, so I'm scoping the input to the amplifier. I've removed the fuses on the left and the right with 2 probes, and the IC is back in. Oscillator is connected to the input point, so I'll give it a little bit of gain, and I'll turn the load on, well, the thing on. And there we go, we've got an output, and they are out of phase with each other. This one is measuring the left channel, so that's the one that's in phase. This one's measuring the right channel, that's the one that's 180 degrees out of phase. So excellent. We can now hook up the load to the output terminals and do the one test that I'm dreading. Oh boy. Yep, alright, now it's configured in bridge. Fuses are back in. And yeah, the amplifier is now loaded with 8 ohms. Don't load it any lower than that, obviously, because it will not survive. So I'll make sure my oscillator is all the way down, which it is. I'll apply power. Dim bulb still in circuit. We have relay action. And yes, it is actually driving the load. So, bypass the dim bulb. Oh, here we go. Okay, I've reached clipping at 33.3 volts. About stable there. Yeah, about 30.32 volts, something like that. I'll go with my original reading, 33. 138.6 watts into 8 ohms. I am extremely happy with that figure. It's about 62 odd watts lower than the expected 200, but oh man, I'm happy that didn't blow up, and it's functioning fine. So that's a good lesson to everybody, is to be sure. I'm giving that a little bit of going. I'm going to do a soak test on it now. Not at full power though. Let this be a good lesson to everybody where you choose to buy your transistors from. I don't know if those 2SA 1943s and 2SC 5200s would have survived in this amp. I wasn't going to trust them. I'll do it on another amplifier project later using those transistors and see if we can blow them up. If they blow up, we know they're crap. So I'm happy that this worked out and it's now a functioning module, and that's the last time I have to go in there and repair it. So it's giving us an output, and that's all the main thing that matters. And it's been a good 5 minutes now, so the amplifier's actually been amplifying the same output voltage for about 10 minutes now, and it's still stable. Heatsink's mildly warm. The transistors themselves are slightly warmer than the heatsink, but it's the same temperature as the bracket, but not the same temperature as the heatsink. Now, as for the load, nothing. We all know what time it is now, don't we? It's spacewalk time, spacewalk time. And if you know where that comes from, leave it in the comments below and you win the internet. No, it's time to turn that off. And I'm going to hook up the speaker as a load now. I'll disconnect the oscillator as well because we don't need that. And I will hook up a audio source such as music, and we'll just do a sound test on it now. Alright, the speaker's hooked up. I've got my phone connected with the YouTube audio library I should say, loaded. I've got my ground connection at the input instead of where I had it, just so it doesn't pick up any noise. Speaker's connected, so all I do now is just apply power and wait for that to engage. Right, well, we have a bit of noise being picked up by the input here, which is fine. So I'll just play a track. That is actually one of my favourite tracks, as you can probably tell. So it's working. These transistors are getting probably warmer than the heatsink, but yeah, it's just the nature of those type of devices. So I'm going to disconnect the input, and there's now no noise there, so it was just my input leads and the phone itself picking up noise. So we know that the circuit works, and it works very well, and I'm very happy about that. So what's next for this? Well, it's to continue on with the original project. That is mounting it in its case. I might turn that off now. Mounting it in a case. I'm going to probably use this heatsink that I've already pre-drilled. Just got to drill a couple more holes to mount it. And I do have over here, if I stop banging into things, for some reason wrapped up in a bit of Kodak photo paper, is a piece of square aluminium. It's 200 by 200 I believe, and that is to place the transformer on. I assume this was the bottom of the transformer. As we can see there, the transformer will fit on there just nicely. So that's how I'm going to be mounting the transformer to the case. So that means that the bottom cover of the case will be totally removable and isolated from the rest of the case so you can actually work on it. So I'll be exposing the underside of the circuit board and the preamp circuitry, etc. So it's just what I'm going to do is mount it like that, and I can also drill a hole for a star earth point as well into that piece of aluminium. So everything is separate of the case, because a lot of projects I build, I mount everything to the bottom of the case, which is, yeah, you can do that, but it's kind of messy. And because this is a 300 VA transformer, I'm probably going to go with a 3-unit case, because just to give it enough room. And this will not fit in the 2-unit either, because it's too high. It's like 88 millimeters or something. That's still quite warm. Yeah, so that's going to be the next step. But my advice is, with transistors these days, go with a reputable source, such as Mouser, DigiKey, and RS Components, and avoid everyone else. If you can get it from JCar, sure, go that route, because JCar's stock is usually pretty good. But no, I'm going to end the video here now, because I've done what I wanted to do, which was to get this working correctly as I wanted to do like a month ago, and it blew up. And this is 4 times the charm, basically. So why was I nervous about doing the bridge test? Well, because it blew up the first time in bridge configuration. That's why I was nervous. But see, if I spent more time worrying about things blowing up on power tests, I wouldn't get anything done. Thing is, if each amplifier can produce an output power, a stable output power, into 4 ohm loads, and not smoke, carry on, and blow up and blow fuses and stuff like that, then there is a 100%, we'll say 99% good chance that it will work just fine bridged. And remember, when bridging any stereo amplifier, both amplifiers have to be the same. So the same brand, same design, same output stage, everything. Otherwise it's not going to work. It may work, but it may not work too well. So we're almost getting double the output power of the 4 ohm load test between each amplifier, which is to be expected. They say in a perfect world, which it's not perfect, that you should be getting 4 times the output of a single amplifier, but in reality it's more like 2, maybe 2 and a bit, and it depends on your output stage design and the actual amplifier design itself. Is can it even do that and get up to that power? Yeah, well, it's debatable. But yeah, it's not the 200 watts that I initially wanted and was intending to design it for, but I'm elated that it's producing 138 watts clean power into 8 ohms and doesn't disintegrate. So yeah, I'm going to leave this video here, and I hope you enjoyed it. Now if you did, please remember to go down below, like, comment and subscribe if you haven't done so already. And this is the Astro 30, very happy saying, see ya, have a great day. Marvellous.